So hello and welcome everybody to our today's webinar on 5 things you should know about cross-platform app development. To give a little intro to our speaker today, and yes, it's going to be unfortunately only one speaker. In the advertisement, we had Florian as well, but he unfortunately caught a throat infection, so he's not able to speak. He's already getting well again, so no worries. And it will be just Tobias Becker today in the afternoon, who will talk to you about 5 things you should know about cross-platform app development. And Tobias is for 5 years with us now at Intive, and he accompanied a lot of mobile app projects, being it native, being it cross-platform development. He's a principal software engineer and solution architect, and now I will hand over to him so that he can guide you through the webinar. We will have a bit of input from him, and then afterwards we will have some time for questions from your end. So if you have questions during the event, just note them. We will come back to them once Tobias is done with his lecture. So have fun, and over to you, Tobias.
Okay, hello everybody. I'm just making sure I'm not muted. Okay, great. Also from me, a warm welcome to everybody and welcome to our webinar. So since Tobias already introduced me, I don't have to do that myself, and we can jump right into the content. So today, as you already read in the invitation, it's about 5 things you should know about cross-platform app development. And that's not everything we're going to tell you. We're going to have a couple of more topics around that. So let me start by giving you a short overview about what I'm going to be talking in this presentation. We're going to start with an introduction to the mobile ecosystem, just quickly looking at some numbers and getting a feeling of sizes in markets of mobile applications. And then we're going to jump into the more interesting things, this being a new generation of development tools, namely being like web and cross-platform tools and not only native Android and iOS development. After that, we're going to come to the point that gives the name to the presentation. This is like the 5 things you should know about cross-platform app development. And after we've looked at that, we're going to have a short section about what at Intive, our cross-platform tool development tool of choice is, and how to find the right approach for your specific project. Good. So let's jump into the introduction right away and start with some numbers. Overall, at the current state, we have around about 4.41 million applications in the 2 biggest app stores. In the Apple App Store, we have about 1.84 million, and in the Google Play Store, it's 2.57. Overall, we have by now, and this number is from August, we have 204 billion total mobile downloads. So that's quite a large number of mobile applications being downloaded to the phones worldwide. And this is not everything. It's just also, of those applications, the users spend 90% of their on-screen time in applications. The rest goes to system browsers, settings, messages, phone, and stuff like that. So that's quite a high number. So the applications that we're writing really get the attention of the users when they look at their phone. And yeah, Google Android and Apple iOS, we know both systems possess over 99% of the global market share currently. If we look at the blue rectangle, we can see that the share of those two is really big, and only a few other mobile operating systems survived, by Samsung, KOS, and Windows, all having below 1% market share. So that's for giving just some guidance when it comes to numbers. And then we have the most prominent providers, iOS and Android, or Google and Apple. A few years ago, the development camps have split into these two dominant streams. And then the other operating systems kind of disappeared from the market as those two rose. And they're pretty different, and most of you might know this, but let's see why and how they're different. iOS is built and controlled by Apple, and it is a closed system in contrary to Android. And why is Apple doing that? Apple is building a closed system so they can provide users with the best possible hardware and software integration, and they can achieve a really important thing, which is having the same experience for all iOS users across devices, across operating system versions. Everybody has roughly the same experience, of course, changing a little from version to version. If we look at Android, however, this is almost completely different. It is an open source project which was launched independently in the past and is nowadays led by Google. And since it's open source, it's not bound to specific hardware. So there are many different manufacturers building devices that run Android, and some of those add their own custom UI application on top of implementation, on top of it. So the experience of a user having an Android device in their hand is quite different depending on which device you're using. And that is a thing which is interesting because it raises testing and development effort. Applications for iOS and Android are written in Swift for iOS, previously being Objective-C, and Kotlin for Android, or previously was mostly using Java. So that should be enough for an introduction into the mobile ecosystems. Let's go to the next point and move on to a new generation of development tools. So if you don't want to build your application natively for whatever reason, and we're going to come to the reasons a little bit later, you have different tools that you can use to still publish applications. The first of them is web-based cross-platform mobile apps. So these apps will most of the time be some hybrid solutions that use web technologies and wrap them into a native shell. And these are then distributed through the app stores from Google and Apple. And these applications are most of the times written with technologies like React Native, Apache Cordova, Ionic, and languages being HTML, CSS, and JavaScript. One important thing to notice is that it is possible to mix web and native parts in those hybrid applications. And we're going to have an example for that on the next slide. But popular examples for web-based cross-platform applications are pretty famous, actually. Those are like Instagram, Gmail, Facebook, and Twitter. So some of the most popular apps are actually web-based applications. One of our biggest examples of web-based or hybrid applications we have built at intive is the CookieDo application. CookieDo is the companion app for the kitchen device Thermomix by Vorwerk. It's quite a good example of demonstrating how we can mix web and native components in one application, because this application has the three screens that you see are entirely web-based and embedded into the otherwise native iOS and Android applications. So in this application, you have the Discover feature on the first screen, where you get recommendations what to cook on your day, and you get entry points into other parts of the application. This is completely web-based, as well as the search that you can see in the middle. So the search is completely web-based and works with an online search. And the third part that is entirely web-based is the shopping list that you put your recipes on and that you use for going to shop your ingredients. The second toolkit that you can use, or the second process that you can use for building cross-platform applications, is cross-platform apps using native rendering engines of the platforms. So the most famous examples for those are Xamarin and Flutter. And those apps are written in one language. Xamarin, it's C#. For Flutter, it's Dart. And then they are using the tools of those two providers, they're compiled into native apps. And the UI that you build is rendered with the same engine that is rendering all the native UI of any native application that runs on the platform. The probably most popular Flutter applications currently are the Google Assistant and the Square and the New York Times apps. One example that we've built at intive using those technologies, in this case it was Flutter, is the Oddset application. The Oddset is a European sports bet provider, and the application covers quite a simple use case. So the user gets a list of games that he wants to bet on or that they want to bet on, and then they choose a game, they place their bet and send it to the backend. And once the event is over, they get notified about the result. Interesting side information, this application also allows betting on US leagues like the NBA and the NFL. And this application is built once with Flutter and is available for iOS and Android. And now coming to the last approach that we want to present, how to build cross-platform applications, is progressive web applications. Progressive web applications are most of the time just pretty standard web applications that you can use or navigate to using your browser on your laptop or tablet. But they are a little bit different from standard web pages in the technologies they use and the toolkits, because you can install them on a mobile device and then they appear like they were a mobile app if they run on your phone or tablet. So technologies you use for building those applications are pretty well known in the web space, being Angular, React, and Polymer, of course, using HTML and CSS with them. And some prominent examples that many of you might know are the Washington Post app, Pinterest, and the Forbes app. And those progressive web applications, you can navigate to them in the browser and use them right in Safari or Chrome mobile. But there's also the option to install them on your device by either wrapping them into a native shell with the approaches that we saw earlier, for example, Cordova, or you allow your user to store them as kind of a bookmark on their home screen on their tablet. And then they can launch this application without all the browser stuff around, without the navigation bars and stuff, address bars. And then they would have a full screen application of consisting basically of your website. And that's it for the cross-platform approaches. So let's next come to the point that gives the name to the presentation: 5 things you should know about cross-platform development. So now it's not about technologies, it's rather about the development process and some other factors. The first thing you should know about is maintaining apps and their code base. We all know that native development offers an app that feels just right for the user. You can design your features completely optimized for the device that you publish them for. And those applications most of the time have a clear edge for high performance, right? So if you want to build an AR, VR, 3D rendering applications, you will most of the time end up in a native development language. But it has a downside too, which is if you want to build for 2 platforms, you have to replicate your effort for both platforms. So if you want to support Android and iOS, you're going to need 2 teams and double the effort. Cross-platform apps, however, they are built using a single code base. So you only have one code base, and this obviously reduces the development and maintenance effort, right? Because you're a lot faster and don't need to build the same feature twice for both platforms. Another benefit is that you can or will always build features in parallel for Android and iOS. So you have no different state of completion. When a feature is done on one platform, it's done on the other. And also, one fact that is maybe interesting, sometimes when you build a specific feature for Android and iOS, you have different complexities in building them for the two platforms. Some things might be more complicated on iOS than they are to build them on Android, or the other way around. Using cross-platform development, you don't have that. You always have the same complexity for both platforms. And you have a unified process for updates and bug fixes. Because you work on a single code base, you update your code once, you fix your bugs in one code base, and then you release one code base. And one interesting thing is, especially when it comes to releases and testing, you don't need to coordinate between two platforms. Coming to the next thing you might need to know about cross-platform development is the true cost of developers. I said that the development effort is reduced when using cross-platform tools, but it is not halved, even if you have half the code. Native apps require you to have two development streams, right? You have entirely different code bases. You have separate experts for iOS and the expert frameworks, iOS frameworks, because you need people that are experts in the toolkits to build your highly efficient applications. And since you have two teams, you need to coordinate them to build features at the same time and the same speed. Cross-platform applications don't solve this problem entirely. Yes, you can reduce the team size significantly, and the coordination between two platforms is easier because it's basically just one platform left or one code base left, but you might still need experts for the different platforms because you might run into problems or you might need some libraries or frameworks for your application that are only available in the native languages, and you might need to integrate them in your application. And for things like that, you still need experts in the specific platforms. And also when it comes to user experience, building an app that feels native, you might need people that are experts in the platform to just build the application in a way that makes sense for the platform users. And one also very interesting thing or very important thing is the testing effort. So if you build an application for two platforms, you also have to test it on two platforms. And no matter if you build your app natively or if you build it using cross-platform tools, you still have to test it on both platforms. So in that regard, you won't really reduce the effort. The third thing you need to know about cross-platform development is early stage and low budget apps. So one way you can see cross-platform development is you can see it as an enabler. Cross-platform development enables you to quickly create proof of concepts for your idea, for your product idea. You can quickly build a prototype to verify that the idea that you came up with makes sense, that it works, that the users like it. And after validating your idea, you can even build a minimum viable product and speed up that building process using cross-platform development tools. It also can be seen as an enabler for companies, especially for new or early stage companies, because you have a reduced cost for quick rollout to multiple platforms. You don't need that big of a team. You just need a few developers to build an app for both platforms, and you can quickly test the potential of your ideas. And one thing that's not to forget is if you create a POC or an MVP and you learn that your idea is working, that users like it and want to see more of it, using cross-platform development tools, you can maintain the momentum after a successful POC or MVP. And all of those facts that we've seen so far lead to this fourth point: increased business gains. So if you use cross-platform development, you're going to get some gains for your business. You have the reduced need for domain experts, as we already learned a few slides ago. You have reduced development cost, and also a faster time to market. And you get in with reduced domain experts, reduced cost, and faster time to market, you get both platforms covered using cross-platform development tools. So in the end, using cross-platform development tools, your business can gain a lot of momentum by quickly assembling a smaller team and testing your product ideas with real users in almost no time. But we don't only have the positive things that you need to know about it, you also need to know where it falls short, right? When, under which circumstances is cross-platform development not the right tool for you? The first thing to look at is applicability. Cross-platform development is not a fix-all solution. Native apps still run closer to the hardware, and they allow for more optimal hardware integration. So depending on your use case, cross-platform development might just not be the right thing for you or for all use cases that you want to build. Also, an important thing to consider is stability. Not stability of your code, but rather stability of the tool and the tool set and the tool chain that you use. So using cross-platform development adds an additional layer of technology that you depend on building your application, right? So you don't only have iOS and Android or Apple and Google as dependencies and their stores, but you also have a third-party provider that you need to always update their technology, right? So if a new version of iOS or Android is released, you need your cross-platform tool to adapt and to update their tooling to support all those new technologies and features of the platforms. And we know that the native platforms have been here for quite some time now. But the new tools, we already have seen some of those disappear. So you need to ask yourself, what's the trend in 2 or 3 years? Do I need a technology that lasts for a long time? Or do I only want to build a POC and I don't care about what happens in 2 years? That were the 5 things you should know about cross-platform development. And now let's jump into what is Intive's cross-platform development toolkit of choice. You might have heard it from how I talked about the technologies earlier. Our toolkit of choice is Flutter at this time. So what is Flutter? Flutter is an open source SDK developed by Google, and it's designed for cross-platform mobile app development. Flutter is advertised by Google with 3 main features, and those are fast development, expressive and flexible UI, and native performance. So let's look into these and see what is interesting about them. Fast development. Why is Flutter providing such a fast development? The feature that they advertise here, and which is actually pretty great, is hot reload. So when you start up your application in an emulator or on your device, you get hot reload. Once you change your code, it immediately reflects those changes in your application on the emulator or on your real device. So that enables you to build UIs and to modify UIs really, really quickly. And staying in the UI, the UI of Flutter and how you build UI with it is really, really flexible. So they have a lot of built-in widgets, and those widgets support both material design and the so-called Cupertino, iOS flavorish designs. And they have really a lot of UI elements built in already, and all the navigation behaviors and all the things that make an application just feel right and native to the platform. And the last thing is native performance. The application is written in a foreign, I'd say, language, right? It's not the native language, but the native compiler for Dart compiles it into ARM machine code. And that runs directly on the hardware of the device instead of being JavaScript that's interpreted at some level and you gain some you lose some performance. With Flutter and native ARM machine code, you get almost native-like performance on your devices. So why do we love Flutter at intive? We love the hot reload feature because it speeds up development times, right? So if you get instant deployments to your test device, you get instant feedback if the changes that you just made were good, if they were working. So this enables us to create more beautiful and powerful UI in less time. And it also makes much more fun building applications this way. The second thing we love about it is you have a cross-platform tool and applications that you build cross-platform, but they feel native when you deploy them on the device. You have a single code base, but the customizable widgets, they allow you to create a native look and feel. So in the end, an iOS app that you build with Flutter feels like an iOS app, and an Android app feels like an Android app. And last but not least, Dart, the language that you use for building Flutter apps. It is very concise, it is very powerful, and also it is easy to learn. And in the current times where mobile development is changing, it is good to have a language that is easy to pick up and powerful when using it. So an interesting question might be, when is Flutter the right choice from a more technical point of view? So we learned that Flutter is the right choice for an application if your use case is rather simple. If it's not very dependent from any hardware features and 3D rendering things. So if you look back to the Bets app that we had, where you just display some things and you send requests to the backend, you get information back, and that's most of the things you're doing without using hardware acceleration. Flutter is a really good choice for application. And Flutter fits especially well for MVPs that you need to build quickly and for proof of concepts and prototypes. That doesn't mean that it doesn't fit for market-ready applications that will last for a few years, but it's just especially well for quickly building things and validating your design. But where's Flutter not yet ready? So Flutter is pretty far in its state, and it's really a good tool, but it's not really a fit for AR or VR applications yet, because those need the application level running closer to the metal. And also you have some restrictions with advanced maps like turn-by-turn navigation and with digital rights management and videos. And that brings us to the last point of the presentation for today, which is how to choose the right approach for your project. So we've prepared a few questions that you should ask or can ask yourself before starting your project to find out which of the technologies that we presented today would be the best to start your project. The first question is, do you need a mobile app as cheap as possible? If yes, ask yourself if you need hardware functionalities like camera or GPS. If those are a must or not. And if they aren't a must, hybrid applications using web technologies like React Native, Cordova, and Ionic are a good fit for your application. If you need the hardware functionalities like camera and GPS, and you don't need the mobile app as cheap as possible, the next question you need to ask yourself is, are you okay with having limited performance if it reduces time to market? If limited performance is okay, one other thing to consider is, are you building an app to extend your existing web application? So do you already have a web application and just want to expand it to the mobile channel? If no, so you're building a completely new application, cross-platform app development using Xamarin or Flutter might be the right thing for you. If you just extend your system by a new application and you have web applications already, progressive web apps should do the trick for you. And if you're not okay with the limited performance, so if you need the highest performance possible, and you're okay if the time to market is a little bit longer, you will have to go with the iOS and Android native applications. Okay, let's summarize what we just learned today and what we talked about. Cross-platform development can enable you to quickly throw your ideas at the market. You can build your applications with a smaller team and make the best use out of a small budget. And Flutter specifically is a great tool if you want to build a native-like user experience, if you want to have almost native-like performance, and if you want to have the best possible development speed. And now it's time for your questions.
Tobias, opening the who's asking, how do you see Flutter integration with things like Google Map?
Sorry, you were just cutting in and out, but let me read the application. So it was, how do you see Flutter integration with things like Google Maps, right?
Yes.
So that depends on how you want to make use of Google Maps. So if you want to only use basic features like showing a map and putting some markers on it, maybe drawing a route or something, the maps functionality built into Flutter would be just fine for you. When it comes to turn-by-turn navigation and more advanced map features, it might be more complicated. But still, in that case, and we've seen that in articles being posted, is in that case you could still use the Google Map libraries and integrate them into your application. So you would kind of build a hybrid Flutter application, putting some native implementation of your Maps features into the otherwise Flutter built application. Hope that makes sense.
Thank you. Next question. How do you compare Xamarin and Flutter?
Oh, that's a good question. So we've tried both in the company, and Xamarin mostly in the context of companies and projects where .NET was really strong in the ecosystem. And from a developer's experience, I didn't build a Xamarin app myself, but I've talked to the developers that had built these. They said that it was not as elegant, as easy to use as the native tool sets, and in comparison to Flutter, it's a bigger and a slower ship. That should be a really good comparison. So Flutter is the younger framework, and it's more modern, and Xamarin is the bigger cruise ship. That might just be the right thing for you if you have a lot of .NET developers already, if you have .NET applications that you want to extend. It depends on the use case, but Flutter is the more modern technology.
From Juan Manuel. If I already have an app in native code, but I want to continue in Flutter, do I need to rewrite existing code, or can I somehow use the native code into the new Flutter app?
That's a good question, and that continues what I started to say in the Google Maps question. So Flutter has the possibility to integrate native parts into a Flutter application and it also supports being built into parts of a native application. So you can do it both ways. You can extend a native application with Flutter features, or you can build a Flutter application and embed your native features. So short answer is yes, you can use both together, and no, you don't have to rewrite all your native code.
Thanks. Next question is a long one. When describing pros and cons of cross-platform development, you didn't mention the availability of human resources. From what I've heard, it's harder and thus more expensive to find cross-platform the learning curve for each of the technologies is.
Okay, let me just reread the last sentence because you were cutting out, or I was. I hope it's not me. Also, it would be interesting to understand what the learning curve. Okay. Yeah, availability of human resources is an interesting fact. And yes, it might be harder to find developers for cross-platform application development. It depends on which approach you use, obviously, because if you go with web-based cross-platform development using React, Angular, React Native, there are quite a lot of people knowing HTML and JavaScript out there. When it comes to Flutter and Xamarin, yes, you're right. It might be harder to find people profound in those tools and languages. But what we've also seen is that Flutter, being so modern and being kind of hyped at the moment, you can find a lot of people that already learned those technologies and are looking for a new job and might be willing to join your company. So instead of seeing that as a blocker, I think it's still a good option to find people, especially when it comes to the more modern technologies. For the learning curve, so what in our experience, the learning curve for Flutter, when you come from native mobile development, is not that steep at all. So the developers in our company that moved from native development to Flutter, they were all pretty happy with how they're learning, how they make progress, and how they learned the new technologies. They said it goes really quickly. There's some architectural things that you need to wrap your head around, but once you've got that, you can get started in the new platform really quickly. On the other hand, if you come from mobile native development and you want to jump into web development, that learning curve is a bit harder because they are more different than Flutter and the native tools.
Next question from Scott, and I hope I'm not cutting again. If you start in Flutter with a simple set of features, but then add new features at some point that needs hardware or some native specific aspect, do you start over with native code?
That's a good question. I first misread it and read, do you start with Flutter or with the native code? Which would be an interesting question too, because I would say start with Flutter. And but to get to the to the actual question, I wouldn't start over with native code. In that case, I would first see if I can use the native embedding features that Flutter gives you, and see if you can build your feature in native code and just embed it to your existing Flutter application, so that you don't have to rewrite your whole application, but you just build that one feature in native code. So I would try and see if that works. If it doesn't, might not be the best situation, but in most of the cases, I'm pretty sure that works.
Thanks. Questions continue to pop in. Next one, as Flutter is supposed to also build for the web, is such function already production ready?
That's a good question, and to be honest, I don't know. Last time I've checked the documentation in August, they said they are close to having it production ready, but it was still in beta. But given the speed of development for the Flutter platform, I would assume that it doesn't take too long for the web building to go to production.
And the next question kind of connects to that. Flutter for native app or front ends for Windows and Mac, is that getting used?
I'm not sure if I'm getting the question right, but I'm assuming it's about compiling Flutter applications into native front ends for Microsoft and Mac computers, laptops, basically. I haven't seen it in use, to be honest. So what I'm seeing most on the Mac, at least, is being web applications wrapped into Electron applications. For Flutter, I haven't seen it yet, and I don't recall a project of any of our clients that has used that yet. So I'm going to be honest, I'm not sure.
Thank you for that. So for the moment, we have all the questions. No, we don't have all the questions. So just trying to mark it as a question so I can publish it, but somehow it doesn't work. So I'm just reading it out. How much can the time to market be reduced with Flutter? Or how much faster can you develop, and therefore how much can you save compared to native development?
That's a really interesting question, because it heavily depends on your product and on your project setup and what you want to build for. So if you want to build for 2 platforms, but you only build for the newest versions of any OS, you can also reduce the testing effort by quite a lot. If you build an application that supports like the 2 latest major versions of operating systems, which is pretty common, and have the same feature speed for 2 platforms, I'd say you can save round about 30-35%. But don't judge me if that doesn't realize in your project. But I'd say gut feeling is about 30-35%.
Thank you. And next question. Would you consider Flutter even if only one platform, for example, Android, is needed? Would it be still faster?
Oh, that is, again, a very good question. And I start with my standard sentence, which established now, is it depends. It depends on a different thing now. It depends on how your team looks like, what your team looks like. So if you have people that are strong in the Android platform, it might be the better way going with Android. If you don't have a team at all, I would say look for both specialties, look for Android developers and Flutter developers, and see which people you can get, if time is absolutely crucial for you. If it's important, if you assume that in the future, at some point, you might need the second platform, I would go with Flutter. And if you say, no, Android will be fine forever for me, I'd say go with Android native. Because yes, the hot reload feature enables you to develop things faster, but Android is still the native platform. And also the thing that you might need to consider is if you go with a native Android, in that case, you don't add another level of dependency into your tool stack.
Okay, thank you. Next question is regards to QA. Is there a toolkit for
Ooh, that's a very interesting question. And in a way it is, and in another way I'm not sure. So I'm not sure if there's native tooling for automation tests, like automating UI tests on Flutter. I read something about it a few weeks ago, but I'm not sure about the state. But if you use automation on tests and use things like monkey tests and technologies that start up your application and then just use it by tapping on the screen and entering information, those will still work no matter which technology you used to build the application. So if there's nothing natively available for Flutter, I'd look for something that works with a readily like finished application that's just running on their device.
Okay, thank you. Next question is on the ecosystem. How mature is the Flutter ecosystem? Things like third-party libraries and integrations.
I'm just gonna read the question myself quickly. How mature is the Flutter ecosystem? Things like third-party libraries and integrations. What I've seen in the last month is that it was very rapidly being developed. So the ecosystem is growing and growing, and it is in a state right now that we are seeing it as a production ready tool. So we're actively consulting our customers to use Flutter, obviously if it's the right choice for their use cases. So we see it as a really mature system, and most of the things that you need for mobile applications and most of the third-party libraries are available for Flutter already. And yeah, things that aren't are really easy to bridge into your application.
And still questions. So very interested crowd today. Fast Flutter supports new features introduced by native platforms like fingerprint login, face recognition, and so on and so on.
Good question. I cannot name it to you in days or weeks, but I've learned in the past that Google is pushing Flutter so strong that usually it supports the new native platform features really, really quickly. And since those features are available in beta builds, most of the times a few weeks before they are released to the public, um, I would say they are almost there before you need them on the platform. So short answer, really quickly.
Okay, thank you very much. So we have basically reached also the end of the time that we wanted to spend with you tonight, 50 minutes. There is actually one last question that is so I'm going to answer it. The question is if so. First, thanks to you, Tobias, and thank you also from my end for bringing us a fantastic webinar. Do you plan to share this later through social media channels? So right after the meeting or a couple of minutes later, you will receive the recording of this webinar, so you can have a look at it again. You will also receive the presentation that was shown today, so you can have a look yourself. Add this also to our publicly available YouTube channel. So if you want to rewatch it or if you want to share it with your colleagues, you can already use the link that you get later today. But otherwise, you will have to wait a little bit more. So thanks everyone for joining in. Thanks a lot for plenty of questions that we got today. I think those helped a lot for us to understand basically what you can actually Flutter. So with that, I'm basically closing, wishing you a very nice rest of the day. Stay safe and see you next time. Take care. Bye bye.
Bye.